Welcome to the Lessons from Lab and Life podcast, brought to you by New England Biolabs. I'm your host, Lydia Morrison, and I hope our podcast offers you some new perspective. Today, I'm joined by Genes in Space Program Outreach and Communications Lead, Katie Martin, as well as last year's Genes in Space competition winner, Pristine Onuoha, and her mentor, Ana Carla Cepeda Diaz. This month, Pristine's molecular biology experiment will launch into space and be performed on the International Space Station. Pristine, Ana, Carla, and Katie, thank you so much for joining me today.
Thanks for having us.
Thanks for having us.
Pleasure to be here.
I wanted to start by saying that I'm so bummed that we didn't get to record this podcast in person. We were postponed, unfortunately, by a snowstorm, but I'm really glad to be here over audio with you all today because I wanted to really have you share with our audience what the Genes in Space program is all about. So I wanted to start with Katie. I was wondering if you could explain the Genes in Space program to any of our listeners who might be unfamiliar with it.
Sure. Yeah. So Genes in Space is a science competition for students in middle school and high school. It's an ideas contest. So we ask students all throughout the U.S. to tell us what biology experiment they would want to see done in space. What question can we ask that'll give us some information that'll help our future as we become, better and better at space travel. And so it's really an ideas competition. We want to excite students around the ideas of space and engineering and science. So we do that by offering this free contest. The grand prize is we launch one winning experiment to the International Space Station each year where it gets carried out by astronauts. But we have, hundreds and thousands of students who participate each year and get to kind of learn a little bit about space, about biology, and kind of start off their career as a science researcher if that's something they want to do.
Yeah, so amazing. Such an inspirational competition. How many winners have there been?
Gosh, so Pristine is our 10th winner, and this year we are in the process right now of selecting our 11th.
Amazing. And has everybody had their experiments launched into space?
Every winner that has been selected has, except for Pristine, but we're working up toward launching hers in just a couple months. But yes, all the 9 winners that won before Pristine, they've all had their experiments launched and completed on the ISS.
That's amazing. Were there any key milestones that resulted from the program or from the students' experiments?
Definitely, yeah. So the interesting thing about the field of space biology is it's such a young field. There's just so little that we know about how life responds to the conditions of space. And right now we're in a stage where we're just proving the basic technology that you need to answer fundamental biology questions. So all the tools, all the techniques that we use every day on Earth, millions and millions of times in labs all across the world, a lot of those techniques have never been done before in space. So it's a really interesting time when we're proving some of the basic technology and establishing the basic toolkit that we're going to need to get critical answers to biology questions. And the exciting thing is our students have been part of building that toolkit, that space biology toolkit that is growing on the ISS. In 2016, we launched our first student experiment to the ISS. That was designed by our first winner named Anna Sofia Bogorayev. She was responsible for the first PCR experiment in space. PCR is a way to copy a DNA sequence you're interested in. And this is like an essential method, and it happens, thousands, maybe millions of times in a given week on Earth. But it had never been done in space as of the year 2016. And so as a high school senior, Anna Sofia got to be part of that groundbreaking investigation. And then a few years later, in 2019, we had a team of students design an experiment that used CRISPR to answer a space biology question. That was the first use of CRISPR gene editing technology ever to be done in space. I think it speaks to where we are, in history. We're at a time when we can be really inclusive and invite students to break some of this new ground with us. You don't have to have a PhD or an MD to design a great experiment and see it launched to space.
Yeah, so exciting. And what a phenomenal accomplishment for the high school students who win your competition too, and to have that opportunity to really contribute to important work about how we're going to be performing science in space in the future. Just really amazing stuff. How did the students go about applying for the competition?
So every year we open our application in January, we close it in April. So it's open all spring. And it's a free competition. We want the barrier to entry to be as low as it can possibly be. So to apply, you basically have to write like a 1-page proposal to us saying, okay, here's the question I want to answer. Here's my hypothesis for what I think we're going to find. And here's how I'd approach that problem. It's a substantial writing exercise because we have to make a really important decision based on it, but it's definitely doable within reach for middle school and high school students.
Pristine, I'm curious, how did you hear about the Genes in Space competition?
Yeah, so I first heard about the Genes in Space competition through my school's Women in STEM club. And so I was really drawn to the opportunity because throughout my life, I've been really curious about the world around me, especially in regards to biology. Like before Genes in Space, I had done research in aquatic ecology, and I had always been most interested in like my biology classes. And so looking at the Genes in Space opportunity, it was an opportunity for me to just dive deeper into research, really answering scientific questions. And I also saw it as an opportunity to take my interest for biology even further because it was specifically space biology. And so I was just really excited to get into that opportunity. And so I didn't start off in the program with the space biology background. But one of the first things I did was just try and learn about the field because, as Katie said, it is a really new field and there are so many different areas you can explore in it. And so throughout my process of exploring space biology, I learned just different aspects, different things coming from the field. And so I got drawn to a specific opportunity.
I love that you learned about the program through your Women's in STEM club. That's so great. I'd love to hear about your experiment. Can you tell me about the experiment that you designed and, what you plan to be able to observe in space travelers?
Yeah. So initially, one of the first things I did was just start by exploring the field. And that kind of led me to reading about the astronaut twin study. And I was reading that article. One of the things that really stood out to me was how astronauts in space experience a genetic change that's linked to their aging. On our chromosomes, there are these genetic sequences that cap the ends of our chromosomes, and they're called telomeres. And on Earth, telomeres normally shorten as we age. But what I learned from that study was that in space, astronaut telomeres appear to become longer. And so it kind of brought up the question of whether astronauts in space may be aging differently. And so one of the biggest mysteries of surrounding this phenomenon was that the cause of it was really unclear. And so after noticing this gap in science and scientific knowledge, I was really keen to just develop an experiment that might help us get closer to figuring out the truth around that phenomenon. And so my hypothesis for my initial experiment was that astronaut telomeres are getting longer because of just a difference in cell proliferation. So the proliferation of certain cells. And that was the experiment that I initially submitted for the Genes in Space contest.
That's so great. And so you had the opportunity to work with a mentor to develop your experiment further. So what's it been like working with Anna Carla?
It's been a really great experience working with Anna Carla. I remember that throughout the experiment development process, when I became a finalist, that was when we were paired. And so as I had been developing my proposal, we got introduced to different constraints that our experiment had to conform to. And so one of these was that our experiment couldn't involve astronaut samples. And so it involved me and my mentor having a lot of creativity to kind of design my experiment around that and just have it adapt in a way that would still stay hold true to my initial experiment and helping it stay relevant to the goal of understanding how astronaut telomeres might change in space.
So how are you planning to investigate that?
So initially, the experiment dealt with telomeres. And so as we've been developing it further, an important part of my experiment was that it would involve quantifying the length of telomeres. So basically measuring like the length of the telomeres, but then taking a step back. This is a tool that isn't like on the broader scale, experiments aboard the ISS. For those experiments, you can't measure DNA length. And so with that, we thought, how could we adapt like this aspect of my experiment and make it more applicable to different kinds of experiments? And so that led us to what we've been developing now, which is a test that will allow scientists and astronauts aboard the ISS to compare DNA of different length in order to detect length differences and have an idea of the lengths of those DNA. And so there are the implications for this are pretty broad in that it can be used for genetic monitoring. Say if you wanted to see if an organism on space experienced genetic changes, because being in space, it's common for you to experience like genetic changes just because of all the radiation and the environmental stress. So I think that's really relevant to that situation. It also is relevant to future technologies that will help scientists aboard the ISS quantify DNA length. So going back to my original telomere proposal, as well as like other kinds of scientific experiments on the ISS. So with that test, the ability to detect DNA length differences, it takes what was a previous like constraint for research aboard the ISS and just will help broaden the field of what's like feasible to be investigated in space.
Yeah, I love that. I think that's a really great example of how the scientific process works, right? You study something, you research something, you kind of find a question about it, you work out a hypothesis, and then you start to really get into the nitty-gritty of how to investigate that issue and explore that issue. And then often I think you find that maybe what you're originally thinking about might not be the best application of the investigation. And so you end up, changing directions a little bit and adjusting your experiments. So I think that's really interesting. I'm curious to hear from Ana Carla. Ana Carla, what has the mentorship experience been like for you? Is this the first time you've been a mentor?
I've been a mentor for 3 years. Though technically, Pristine is my fourth mentee because my second year I had a pair of sisters who won the competition together. So who became finalists together. They did not win the competition. So yeah, I'm a third-year mentor, and it's been really wonderful to work with Pristine. The part that I enjoy the most about being a Genes in Space mentor is getting to know each student and their interests, how they're unique, what they want to challenge themselves with. It's a completely different journey scientifically, but also personally with each of the students. And so it was a privilege really to be part of her life this summer and into the fall. Since she won, we got to continue working together on her experiments. I really enjoy hearing all of her ideas. She's so smart and creative, and she would always say something unexpected, some new connection that I didn't think of before. So it was really wonderful, very refreshing, and I really enjoyed my journey with her.
It sounds like a wonderful experience, and congratulations to you both for being selected as winner and mentor winner of the competition in 2022. It's a huge accolade, I think. So what an honor.
With Ana Carla, we were really able to she helped me dive deeper into the experiment process, just helping me just straighten out the details and just really just go through the process of developing my experiment in a way to make it more robust. I remember as like the presentation date got closer, I would always ask her a lot of questions, just things to help make my experiment and my proposal more thorough. And so she was really helpful in that. And also she would always provide me with a lot of guidance and stuff, but she also like gave me the independence and freedom to kind of like direct things in a certain direction. to just have the choice whether to include a certain detail or not, or to emphasize a different detail. And so having that independence really helped me feel like a true scientist, just having that option to kind of direct my experiment in a way that I was really happy with for my final presentation.
Yeah, it sounds like you guys have developed a really amazing relationship. And I think it's pretty clear to everybody here today that you are a true scientist, Pristine. So we can't wait to see how your experiment goes, and we can't wait to hear about what you do next. Do you have a date set for the launch of the experiment yet?
Yeah, so currently the experiment is set to be launched on June 3rd. That might shift depending on scheduling, but that's where it's set to be. And I'm just really excited to see an idea that started off initially in my head become a reality and just watch the rocket take off with my experiment inside. I'm really looking forward to it.
Yeah, I'm sure you are. And I'm looking forward to hearing more about it. And I'm sure our listeners will be looking forward to tuning in for the launch. Thank you all so much for taking time out of your busy schedules to share your story with us today. And there'll be lots of links in the transcript of this podcast if anybody wants to learn more about the Genes in Space program, how to enter, past winners, and Pristine's experiment. Thank you all so much.
Thanks for having us.
Thank you.
Thanks for joining us for this episode. Be sure to check out the transcript for helpful links for further resources. And to learn more about the Genes in Space program, visit genesinspace.org.